atoms are the invisible architecture of everything we see and touch. Hello, I am Mark from Mentivia. Welcome to our exploration of the fundamental building blocks of all matter, atoms. Everything around us, from the air we breathe to the complex molecules within our bodies, is made up of these tiny, intricate structures. Today, we'll delve into the core components of an atom and understand what makes each element unique. We'll examine how protons determine an element's identity, how neutrons influence atomic mass and stability, and how electrons shape chemical interactions. At the very heart of every atom lies the nucleus, a dense central core. Within this nucleus, we find subatomic particles called protons. Protons carry a positive electrical charge and are absolutely crucial because their number defines the element itself. For instance, any atom with 1 proton is hydrogen, and any atom with 6 protons is carbon. Sharing the nucleus with protons are neutrons. As their name suggests, neutrons are electrically neutral. They carry no charge. While they don't influence an atom's identity in the same way protons do, they are essential for the stability of the nucleus and contribute significantly to the atom's overall mass. Without neutrons, the positively charged protons would repel each other, causing the nucleus to fall apart. Orbiting around the nucleus in distinct energy levels or shells are electrons. These subatomic particles carry a negative electrical charge, balancing out the positive charge of the protons in a neutral atom. Electrons are much smaller and lighter than protons and neutrons, but their arrangement and movement are vital for chemical reactions and how atoms interact with each other to form bonds. So, to summarize the basic structure, a central nucleus containing positively charged protons and neutral neutrons, surrounded by negatively charged electrons orbiting in specific paths. This fundamental arrangement dictates the unique properties of every element. Now that we understand the subatomic particles, let's look at 2 critical numbers that define an atom: the atomic number and atomic mass. The atomic number, denoted by the letter Z, is perhaps the most fundamental. It is simply the count of protons found in an atom's nucleus. Because the atomic number is unique to each element, it's like an atom's fingerprint. For example, all atoms with an atomic number of 1 are hydrogen, and all atoms with an atomic number of 8 are oxygen. In a neutral atom, the number of electrons is equal to the atomic number, ensuring a balanced charge. Moving on to atomic mass. When we talk about an atom's mass, we're primarily concerned with the particles in its nucleus. The atomic mass, often referred to as the mass number A for a specific isotope, is the total count of both protons and neutrons in the nucleus. Electrons contribute very little to the overall mass of an atom, so their mass is considered negligible in this calculation. For example, if an atom has 6 protons and 6 neutrons, its atomic mass would be approximately 12 atomic mass units. This value helps us understand the different isotopes of an element, which are atoms of the same element with varying numbers of neutrons. In summary, atoms are composed of protons and neutrons in a central nucleus surrounded by orbiting electrons. The atomic number defines the element by its number of protons, while the atomic mass accounts for the total number of protons and neutrons. These fundamental concepts are the bedrock of chemistry and, by extension, the chemistry of life. Thanks for watching. If you found this video helpful, be sure to check out mentivia.com for more educational content. There you'll find completely free e-learnings, videos, and articles designed to deepen your understanding across a wide range of topics. And if you'd like to keep learning with us, don't forget to subscribe to the channel. We've got plenty more coming your way.